Hi, welcome back to the channel. My name is John Olson, and this video is about time segmentation in physics. Someone once said that you cannot step into the same river twice. A river, of course, has always been a literature tool to symbolize the passage of time. As a philosophical adventure, it is used that way to explore the ideal of time passing. It can be, in some fundamental way, a function of the computer power of local processes. While the human eye-to-brain pathway is the fastest of all body sensing and control paths, the human is still limited to a handful of milliseconds, or about 1 millisecond at best, to notice changes and discontinuities. But it gets more profound when you dig deeper down the rabbit hole. If time is a physical thing, there is implied mental connections to those other things with short duration capability, whether destructive like the weather or constructive like light energy and heat and radio waves or a computer math construction. That same philosophy leads us down a road to where the concept of being is more important than the concept of doing. To step in a river of any given name is less an act, although it is an act to be sure, than a bit of data describing that act. So many intensely mathematical studies and serious questions have been raised over the years about the nature and inventions in this category of memory, thought, awareness, mortality, and soul, just to begin with. That the future and past, the purpose and causes we know as reality, are today frequently described as a kind of simulation or matrix. The Western invention of calculus was for a long time our best hope of gripping into the history and future acts of the universe, or of God itself in some religion thinkers' minds. But the Western form showed functions of numbers to have too many discontinuities that required an error check or sequence of sorts to validate them in the form of writing we use to model our world and work in the form of numbers, even imaginary ones. Earlier studies had developed best in Japanese calculus, which was shown to be able to solve problems in finance and market conditions that the methods of European origins was unable to address and solve. Thus, a divide between the East and West formed. In the computer age, information as data structures and indexes, artificial intelligence and inferences from Western math suffered slow and painful burials of vast quantities of work into the subduction zone of apathy that underlies the constant need for new and novel publication. On the positive side of the divide, social science and psychology departments that wanted to use computation developed broad, powerful tools that can be applied to both language and math conventions common to the classical past studies had this added content to their language. This sometimes included diverse variables as time and deep time of the many cultures of the world, in spite of the threat of risk from religious perceptions that had strong and negative biases against writing non-theory as fact-based high culture. It is possible, for example, to quantify the amount of information in any given amount of space as a distance in 1, 2, or 3 dimensions, or more. The number of digits needed to convey that code is given an amount of precise meanings. It's one of the few problems ever resolved in the area arrived to build a control circuit from memories that addressed the need as they developed. What social studies found was that the English language was the race car of all current languages. The Eastern languages did not match the compression ratio of modern English, but they were instead a kind of missing link to socially acceptable relationships supporting data that is woven into the interactions and typically lasts longer and span more sessions of more varied time intervals than the people living in today's United States would find convenient or practical. This helps explain the Western error rate. When computer compilers were invented, they were capable of performing the classical physical fundamentals such as computing a constant used to express values and used to design experiments and evaluate reactions. It meant that classical physics had to change. This today is thought to have been because the classical experiments sought only to define that which caused or seemed to be behind a process as if it was going on in the background at the same time. The peak of this discussion was a brief flash of science group thinking about 1935. The lack of any ability to tie together the various physical constants used in magnetic, electric, mass, gravity, and so forth forced a small group of physicists to more or less go underground. As history records, even with a computer able to converge and digest broad spectrums of available mathematical inventions, the moment had arrived. It became clear that no such unification of gravity and gas laws, electricity and heat laws, mass and restitution, force and waves, magnetic divergence, and static entropic fields was about to be found. This gave rise to various groups of insiders who were disruptive in the extreme in the historic culture of sciences, especially in the area of the study of the universe. The brunt of theory has been aimed at making possible a description of the universe that makes possible both expansion and compression in multiple universes or black hole nestings of almost any possible number of degrees of freedom to move in any direction from any point source and any infinite time segment rhythms relative to each other. Only in this way can the many contradictions to our space measurements and metrics ever be explained. These metrics conflict with everything we thought we knew, most importantly in the second law of thermodynamics, which would need to have it revised to say that the entropy and self-organization of matter are always increasing, but under different initial conditions, like the number of degrees of freedom and the existence of two opposing tensors from two opposite directions on a pivot point, and the dispersion of particles as they float in the soup of expansion from Big Bang or Big Crunch. But it is more simple, although it requires complex geometric proofs, than it is to try to explain things like the constant variations in gravity and other metrics, which are used to always based upon constant values. Even those constant values had to have major adjustments above and beyond the geometric size and shape parameters. Essentially, the constants change rapidly in some locations and environments, but not in others. The constants change most in the smaller geometric sizes and sources of interactions, and no boundary in any size of larger particles has been found to stop this. The practical implications are enormous. If these groups of well-funded and well-organized academics are able to upend the traditions of the original author's works, and many independent labs and independent types of energy transfers, then they will combine into one department regulated solely by them, and censorship of any contradictory conclusions is inevitable. I have had the advantage of being an inventor, and I do not want to see this happen. As the equipment and funds have already gone the way of the dodo and are extinct, the system of patent protection against infringement designed for individuals has long ago collapsed. It also requires that an inventor make constant updates to keep a patent. The law should grant the patent for life, the inventor, with no other restrictions. In my way, there is no destruction of previous theory, and there is no reversion to deep and poorly understood geometries and invented forces and force carriers and tensors, which are intangible and can be manufactured into existence. When given a choice, science has a source of logic rules that the more simple of two solutions should be considered correct. So here it is. We can model all things in math, but so far nobody has questioned that math by using math. It has always been manipulated to the advantage of the speaker, or the observer, or the inventor, or some other charismatic status symbol, a team boss. Look at my gravity formula for real gravity, the constant g. The binary g constant has two formulas. The first is the square root of the quantity, the quantity of 1 divided by the quantity of 2 pi. It begins with two square root symbols. The second, which gives the same result, begins with one square root symbol for the quantity of 1 divided by the quantity of 2 pi. It should be obvious that we should begin with the simple and work to the complex, instead of the other way around, as post-classical and cosmic and pseudophysics has always done. So notice, please, that there is a difference in the speed at which these two configurations can be processed, as well as the number of degrees of freedom that are implied, especially when you add in a scalar, as is commonly done to compare two formulas. In other words, there is time displacement in computation, and possible angularity opposed dualities. In the double split experiment, it is possible to know when two slots appear instead of one. The momentum of a speeding particle is added to its rest momentum. That is, it passes through the slots but does not have any added energy when at terminal velocity at the screen or plate. Because the photon is present when the added momentum of motion is a real number and that photon has no momentum, it is always dissipated at an angle instead of a straight line when in wave form. Having a second slit only decreases that energy over two slits, dividing it by two, dividing it into more than one slit. A single slit strangely works, but never three, or any other group greater than two. Only two act to cause any interesting effects. All this happens when any form of wave or particle goes through two slits. Let me briefly list the usual explanations, and I'm going to omit some of the more radical ones. First, the most used is that there's a quantum effect, and the word quantum is put in front of everything, and even though the two major scientists of Dirac and Schrodinger did not even agree on what is a quantum, they had opposite definitions. Number two, you can say that the particle spin is up or down, but that only happens when there's an orbital of an electron. And number three, the wave function collapses. Whenever you add energy that stabilizes wave energy into a particle indication, it's called the collapse of the wave function. Number four, say the sensor's energy is not a problem, but the fact that a conscious entity or observer is present. Now, that was a design by committee finding that convened in the 1800s. And number five, say that wave-particle duality exists. Well, we know that today a particle is always a particle, and a wave is always a wave. They are not the same thing. But the list goes on and on. A single slit case is not, as we've always assumed, the absolute and only state of any real number either. That depends on the physical world that it rests in and has interactions in pairs or single events. The space probe data, for example, that there are areas of lower and areas of higher gravity background fields. Photons travel faster through a higher gravitational background, even though a photon has no momentum and has no reaction to inertial frames of reference. The difference is from stability, that allows a movement within any inertial constant to be a real number and not imaginary numbers at a minimal energy quantum state. In electrotransmissions, the 1 divided by the quantity 2 pi frequency equals the capacitance needed to stabilize. But the higher the voltage, then the lower the frequency, so that an adjustment of voltage divided by amperage is used as a scalar to transmit over medium range distances. A furnace motor runs this way. Because I have written about this subject in the past, I have free videos online to view. You may recognize that the formula yield is the cosine of the Great Pyramid's peak. This angle is inflected at the four faces and tapered at the fifth elemental junction line, which is the missing top cap. If the leading experts are successful in doing what they feel they have to do to reverse the statement made in the second law of thermodynamics by allowing an open system instead of a closed system, then at least I can document, albeit in a very rare and hard to find way, that their takeover is mostly an attempt to cover up their continued failure, which became obvious in 1935 when teams of professionals doing serious peer reviews under the table at universities in Europe discovered. The World War interfered greatly with their effort. After the war in England, a question began to be examined, which resulted in 1955 and a famous formulation of the best yet recognized law of physics that has ever been put to math. It was the formula for the normal statistical distribution. The word statistics was used only casually as a joke for looking at the bits of precision left over. It was called a method to avoid eating an elephant. The only reason that math professors all over the world worked for 10 years to write and validate a short formula is that every experiment done in those days was very time sensitive. From the trigger for the nuclear bomb to the variations in light waves and optic gun sights and howitzer bombardments, no other progress could be made until it was resolved without politics. The £1 million sterling reward offered by the Crown family of England may have helped a bit too. Even statistical analysis has the revolting habit of asking the question to supply the information of how exactly the party requesting the analysis wants the problem to be solved. It is so easy to make this appear to be a matter of what math convention or computer compiler languages the user wants. But it is more than that. In the return to the infancy of the study of physical things instead of religious philosophy, when the observer and the apparent philosophy was used to substitute for precise and accurate data collection, the two metrics are different things. Furthermore, the old school thinking did not understand that any acceptable dispersion of sequences and non-sequences needed to be compared using statistics. To do otherwise yields only a metric. The physics of the double slit experiment is replete with false claims of measuring the passage of energy over one or the other slits. Likewise, we can never seem to have developed the capability to actually measure a segment of time. What we study seems to yield a product of time, but not ever validate that time as a constant or a background process into which either movement or Maxwell's divergence and convergence, the two parameters of electromagnetic force that manufacture a photon, can be said to compare to. General relativity is essentially an assertion that the number of standard clock ticks that are sent by making the meter equal to the length of distance in the 1 second, because we believe it will define the normal, can be varied as desired, so that the observer of orbital paths, interstellar clouds of gravity stars, and especially pulsars, have a standard that can be fit into a math model. The pressure to do the first to discover something is enormous. Being the last to discover something is considered economic failure and an also-ran that stands on the shoulders of past geniuses. Yet, the last buggy whip made is always the best buggy whip made. With all the hack theories, there is not much risk of being ignored or found to be lacking in any comparison to the reward of being recognized as innovative and even disruptive, using only math and revelations that are invented by definitions of different coordinate spaces where constants can live, like little evil creatures that defy investigation and correlations, that work on human distances and lifetime scales. If an expert wants to be recognized, he or she is better off building devices on a whim and testing them rather than to join the preachers who are preaching only to the choir boys as they pretend to understand time segments, equations, and gravity. Any variations in photon stability would do to begin with. It may well have been that in 1905, the concept of special relativity was an attempt to exploit the 1 million degree corona of the sun as a source of photon stability and so-called gravity lensing. As the secretive Tesla, Einstein, Hilbert, and others were at the time, they may well have to rediscover the fundamental units that are the actual interest in computation and thermodynamics. Tesla called Einstein a harebrained fool when they met. That was the end of their relationship. Tesla was a physical thinker and doer, while Einstein was a liberal interested in rhetorical discussions for their own sake. I'm not saying that liberal arts is in any way sinister, just that you have to be careful to read, when you have time to find a clue, the work of someone who has an education in liberal arts. If the subject is science, some technical physics or technical math, like algebra, believe it or not, will always be a safer read and surprisingly prevents stupid mistakes, no matter what any discussion involves. Thank you for listening.